What if everything you've ever been told about gravity is wrong? What if the force that supposedly keeps your feet on the ground isn't a force at all, but a grand illusion, a misunderstood consequence of something far deeper, far stranger, and far more powerful than Newton or Einstein ever imagined? Buckle up, we're diving into one of the most shocking scientific rethinks of all time: why everyone is wrong about gravity. For centuries, we were told gravity is a pull. Newton said every object attracts every other object with a force proportional to its mass and inversely proportional to the square of the distance. Simple, elegant, and, apparently, wrong. Because when Einstein came along, he shattered that notion. He said gravity isn't a force pulling at all. It's space and time bending, curving around massive objects, forcing everything to follow the path of least resistance. In short, mass tells space how to curve, and space tells matter how to move. But here's the twist: what if even that isn't the full truth? What if gravity isn't a fundamental feature of the universe, but an emergent property, something that arises from hidden layers of information, energy, and quantum activity we barely understand? Let's start where everything begins: space. We think of it as emptiness, a blank void. But according to quantum physics, it's anything but empty. It's a boiling sea of energy, constantly producing and annihilating particles. The vacuum itself isn't nothing. It's alive, humming with energy fields that fluctuate at unimaginable speeds. Some physicists suggest gravity might not come from mass-curving space at all, but from the way information about quantum particles gets scrambled and rearranged. In 2010, physicist Eric Verlin dropped a bombshell. Gravity, he said, is an entropic force. In simple terms, it's not a fundamental force like electromagnetism or the strong nuclear force. Instead, it's a side effect, a thermodynamic reaction caused by the universe's relentless drive toward disorder. Think of it like this: when you drop a ball, it falls not because Earth pulls it, but because the universe is trying to maximize entropy, the spread of information and energy. Verlin's theory shook physics to its core. Because if gravity is emergent, that means space itself might be emergent. Reality could be built from something deeper, a network of information bits, a cosmic code dictating how everything behaves. In that view, the planets orbit the sun not because of invisible pulling, but because the geometry of information in spacetime makes them move that way. And it doesn't stop there. Quantum gravity, the holy grail of modern physics, tries to merge Einstein's relativity with quantum mechanics. And every theory, from string theory to loop quantum gravity, tells us the same haunting thing: gravity is not what it seems. It might be a statistical effect, an average of countless quantum interactions. Let's talk about black holes. For decades, they've been the ultimate test of gravity. Einstein's theory predicted them perfectly, regions so dense that not even light can escape. But then came Stephen Hawking, who proved that black holes aren't entirely black. They emit radiation. They lose mass. They evaporate. And that created a paradox: if black holes evaporate, what happens to the information that fell inside? Does it vanish forever? That would break the laws of quantum physics. To fix this, scientists began to suspect that space, time, and gravity are built out of information. That maybe the universe itself is holographic, a 3D world projected from a 2D surface of encoded data. Gravity, in this picture, isn't a force or a curvature, it's a mirage emerging from how this information arranges itself. Now think about this: when astronauts float in space, we say they're weightless because gravity is weaker. But they're actually still under Earth's gravity, it's just that everything around them is falling at the same rate. Einstein called this the equivalence principle, and it's the foundation of general relativity. But if gravity is emergent, then maybe this feeling of weight and falling isn't a property of mass, it's a property of information flow. What if mass itself, what we think of as matter, is just a condensation of information in a quantum field? In that case, gravity is simply the way this information organizes itself across the universe. The bending of spacetime might just be the visible shadow of something deeper, a hidden code, a substructure we can't yet see. And yet, everywhere we look, we see cracks in the classic story. Galaxies spin too fast for their visible mass. Einstein's equations can't explain that without inventing dark matter, something invisible that makes up 85% of the universe. But what if dark matter doesn't exist at all? Verlin's emergent gravity predicts the same galactic behavior without needing any invisible particles. What if we've been chasing a ghost for decades, because we misunderstood the real nature of gravity? Even more mind-bending, some researchers propose gravity could be negative. Yes, repulsive. They call it dark energy, the mysterious pressure that pushes galaxies apart faster and faster. If gravity can pull and push, Maybe it's not a force at all, but a result of energy balance between two hidden dimensions, one that attracts, one that repels. So where does that leave Newton and Einstein? Not wrong, but incomplete. Their models work brilliantly for predicting orbits, tides, and even black holes. But they don't tell us why gravity exists. They describe it, they don't explain it. In truth, we might be living in a universe where gravity isn't a thing at all. It's a story our minds tell to make sense of a far deeper cosmic code. Every fall, every orbit, every curve in spacetime might be the visible echo of hidden information trying to balance itself. And here's the ultimate twist: if gravity is emergent, if it's born from quantum information, then controlling it might one day be possible. Imagine bending not space, but the underlying data of the universe. Anti-gravity might not require exotic materials, it might just require rewriting the code of spacetime itself. But for now, we stand on the edge of understanding. Every equation, every experiment, every gravitational wave detection reminds us of how little we truly know. Maybe one day we'll find that gravity was never a fundamental force at all, but the language through which the universe whispers its secrets. Until then, remember this: gravity might not pull you down. It might simply be guiding you along the invisible curves of reality's code, a silent rhythm that shapes every planet, every atom, and every thought you've ever had. And if that's true, then the greatest illusion in physics isn't magic, or time, or even reality itself. It's gravity, the quiet trickster that fooled us all. And as we reach the end of this journey, let's step back for a moment and realize just how fragile our understanding truly is. For centuries, humanity believed gravity was simple, a pull, an invisible string holding everything together. Then Einstein came along and told us it wasn't a pull at all, but the bending of reality itself. And now, a new generation of thinkers is daring to whisper that maybe even Einstein didn't go deep enough, that gravity isn't a thing, but a symptom of something much grander. It's humbling, isn't it? To think that every apple that's fallen, every planet that's orbited, every black hole that's devoured light, might all be products of a hidden order beneath the surface of reality. That the universe, in all its vastness, might not even be real in the way we imagine, but a vast ocean of information, rippling, vibrating, rearranging itself, and gravity is simply the pattern that emerges from that dance. We've always sought to simplify the cosmos, to name it, to define it, to measure it in numbers and equations. But maybe gravity isn't meant to be tamed by mathematics alone. Maybe it's a whisper of something deeper, a reminder that the universe isn't a cold machine, but a living, breathing system of balance and exchange. Think about what this means for our place in the cosmos. If gravity is emergent, then we, too, are emergent, patterns of energy and consciousness rising from the same cosmic code that holds galaxies together. The same hidden threads that guide the stars could be the very ones that guide thought, emotion, and existence itself. The boundary between physics and philosophy begins to blur, until the two are one and the same. Every discovery we make about gravity brings us closer to understanding not just how the universe works, but why it works. If space and time are built from information, then every atom, every thought, every moment you live is part of the same computation. You are not separate from the cosmos, you are the cosmos, experiencing itself from within. And perhaps that's the point. Maybe gravity's greatest secret isn't scientific at all. Maybe it's a message, a quiet, eternal truth written into the structure of existence itself. That nothing in the universe is ever truly alone. That every atom, every star, every human heart is part of the same grand equation. That even as we fall, we are never falling apart. We are falling together. So the next time you feel the pull of gravity, don't think of it as something dragging you down. Think of it as the universe holding you close, a reminder that you are part of the same mystery that bends light, shapes time, and births galaxies. And when we finally uncover what gravity truly is, when we peel back the last veil and see the cosmic code beneath, it won't just rewrite physics. It will rewrite what it means to exist. Because the truth about gravity may just be the truth about everything. Until that day comes, keep questioning. Keep exploring. Because the greatest discoveries aren't the ones that prove what we know, they're the ones that show us how much more there is to learn. And gravity, the oldest mystery of them all, is still waiting to reveal its final secret. The question isn't what is gravity? Anymore. The question is, what is reality? And the answer, somewhere between the stars and the smallest quantum flicker, is still falling toward us. And as we close this journey, remember this: gravity was never just about pulling objects down. It's the invisible rhythm of the universe, the silent heartbeat that connects every atom, every planet, every living thing. Maybe it's not a force at all, but the universe's way of keeping itself in harmony, a reminder that everything is bound by something deeper than mass or motion. Every fall, every orbit, every heartbeat is part of that cosmic balance. So when you feel gravity's pull, don't see it as something that drags you down. See it as the universe holding you close, whispering that you belong, that you're part of the same mystery that shapes galaxies and bends time itself. Because maybe, just maybe, gravity isn't what keeps us grounded, it's what keeps us connected.